So we're recording. So let me grab get my calculator. All right. So okay, good. You know what? Let's do 7-1. That way we're still in linear since we just finished 4-1, 4-2 was linear. We'll go ahead and do 7-1 and then we'll jump into quadratics and kind of knock it out. Okay. Solving systems linear equation with two variables. So we've got independent, inconsistent, and dependent solutions or systems. And this is probably the best way that I can put it. You've got two lines. You can only orientate them three ways. So they got to intersect, or they're parallel, or they're the same line. So if it says independent system, then that means that they both intersect in that point of intersection, which is an XY in ordered pair, is the solution. Okay. Now, if they're parallel, we call it an inconsistent system. Okay. But the answer would be a no solution because they don't touch. And then if we say it's a dependent system, then it is the same line mapped right on top of itself, and it touches the entire time from negative infinity to infinity. So that's why it's infinite amount of solutions. Okay. So that should be a little bit of a review for the three types of solutions that you could have for systems of equations. Now, I have some videos that I do for systems of equations. We're looking at it from graphing, looking at it in terms of solving by substitution and then solving by elimination. I can put those up in Blackboard and do that. That's not a problem. And I'll do that later this evening, and that way you can go back to them just in case you need a little bit of a review. You're more welcome to go out on YouTube, but at least you'll hear the same talk and approach. All right, so it says determine whether 3, -3 is a solution to the system of equations. So what it's telling us, this equation, this top one and this bottom one, what they're saying is if you were to graph them, they would intersect at 3, -3. That's what it's saying. Now, in order for that to be true, then 3, -3 has to work in both of the equation, meaning when you plug the x and y in, the left side should equal the right side. So when we're doing this, I'm going to go and get purple. I'll plug in 3 times 3 minus 4 times -3. Excuse me, does it equal -21? Well, let's see. 9 plus 12, does it equal -21? It definitely equals 21, but it doesn't equal -21. So right off the bat, when we check this equation right here, it failed, right? That's what that line between or through that equals right there. Boy, I just messed it up. Let me go back in and fix that. So it doesn't equal, so it's not a solution. Now, let's say that it worked. Let's say that instead of -21 here, it was positive 21. Well, I do not know why I'm yawning. I'm not sleepy. I don't know. But if it did left side equal right side on this first equation, then I would turn around and check it in the second equation, okay? And if it worked in that one, then I could say that it is a solution. All right? Any questions on that?
No.
Okay. The system should be a review kind of for you. So let's look at the next problem. It says, given the two intersecting lines, find the solution. Well, the solution is exactly where they intersect, right? And it'll be a x comma y. So it's 4, 4. So the x value is 4 and the y value is 4. Any questions on that?
No. No.
Oh my, little cute voice.
You might hear her sometimes.
Yeah,
Sorry.
that's okay. That's fine. So they may, like I grabbed this one, they may have one that had two lines parallel, which its solution would be no solution, right? Because it didn't touch. But this is the one I happen to choose. All right, so it says solve the following system of equation by graphing, and then graph them on the axes. So first things first, I'm going to take each one of these and put it back into slope-intercept form. So in doing the top one, if I move this top one, this x, back over to the other side, then what it does for me is gives me this, okay, which in turn the slope would be -1/1 and the y-intercept would be -1. So when we go down here to graph this, we would put a dot at -1. It would go, let's see, it would go down one to the right one. So down one to the right one would be here. And then we can do a line. Let me grab a line. This is, it's chapter 4, but it's section 7.1. So if you're looking in your book, Amadou, you probably got to go to chapter 7. Okay, it doesn't really follow per chapters in the book. It's kind of like takes a section from here, takes a section from there, so forth and so on. It kind of makes its own chapters when we do it online like this. Okay, so 7.1. Now let me, yeah, like that. There. There, it's graphed. Okay, so we can go back up, and now we can look at this one right here. Now, if we take this negative x over to the other side, then I'm left with a positive x plus 5. Now, what that's going to give me is a slope of 1/1 and a y-intercept of 5. Now, that would be up 1 and over to the right 1, right? Positive and positive. So what I'm going to do is I'm going to go here. Did y'all see what I just did? Yeah, that's right. Sorry. Yeah, I second guessed myself. Okay, there we go. Here and then here, right? It's going to go up 1/1, up 1/1, up 1/1, up 1/1. And if I wanted to go change direction, I go down one to the left, down one to the left, and then I'll plot it. And go here. I'm going to go blue. Make sure I grab where I need to here. All right. So what we find is that these intersect at -1, 0. Okay. And that's really what we're trying to find there, is where do these two intersect. So you take it from standard form over into slope-intercept form, pull your slope and y-intercept out, graph them. which you only need the y-intercept and a slope to get you to the next point. And then the point of intersection is negative 1, 0. Any questions on that?
No.
Okay. All right. So remember, we can solve them by graph systems, by graphing. We can solve them by substitution, and then we could also solve them by elimination, okay? I'm going to show you my preference on each. This one says solve by substitution. That's great. I don't have a problem with this. Anytime you have, you're given two equations, but anytime you have one of them solved in terms of one of the variables by itself, like x equals, then this is when I will use substitution. There's an example that shows further in the work that they're both in standard form. It says solve by substitution, and I just don't, because it doesn't warrant that's not the most efficient way. Okay, so when you're substituting, what this says is it says x is equal to all of this right here, 2y minus 5, right? So if I were to come up and place the contents of what x is equal to in here for that x, what that does for me is it gives me, just messed up. I'll substitute the 2y minus 5 in to that top equation, because this was x, right? And we said that x was 2y minus 5. So it substituted the what it was equal to in for that variable. Now I have everything in terms of y, and that's what I'm trying to do. All right, so distribute. That's 4y minus 10 minus y equals to 2. Combine like terms here. That gives me 3y minus 10 equals 2. Yeah. Yep. Okay, just kind of checking things, making sure that what I've done was right. All right, so I am 3y, so I'm going to add. I'll add 10 to both sides. That gives me 3y equal to 12. And then, of course, I'll divide both sides by 3. Y is equal to 4, right? So once I get what the y value is, I can plug it back into this y, and it will give me the x here. So x equals 2 times 4 minus 5. So 2 times 4 is 8 minus 5. So x equals 3. Now, I solve for x and y, but my answer needs to be as an ordered pair, which is x comma y, right, in parentheses. So that's substitution. That's what it's doing. I'll put the videos up. I highly recommend you going and looking at them for just the substitution stuff, and for I think there's like a couple parts on it, part 1, part 2 type stuff, and then elimination. Very good videos, so I'll have those up in there as well. Okay, and again, I'll have those by this evening.
Okay.
Any questions on this one?
No, I got it.
Okay. All right. So, all right. Now, on this particular problem, it says solve by substitution. If we were to take either the negative 2y or the negative 3y to the other side, then it would have one of the equations solved in terms of one variable, right? We can do that. I normally don't do that. I normally do elimination. So and I'm going to let me work this problem both ways, and I'll let you choose on how you want to do it. Okay. So first off, let's just take this top one, move this 3y to the other side. So that'd give me x equals 3y. Isaac, hold on, guys. All right, so I took the 3y, negative 3y over, and it gives me x equals 3y, so I'm just going to plug it into this one. So it'd be 3y minus 2y equals negative 1. And of course, that gives me 1y equal to negative 1, so y equals negative 1. And when I plug that up here, back up into there, x equals 3 times 1, so x equals 3. So that would be 3 comma negative 1. Now, let me do something real quick. Now, that's if you do it by substitution, okay? Let me do something real quick. I'm going to hit pause for now. Let's look at it in terms of substitution. I kind of want to let you see it both ways, or I shouldn't say substitution. This was substitution, right? Let me boom, boom, boom. There we go. This was substitution. Okay, and this method right here is elimination. Okay, and traditionally, if both equations are in standard form, then you would do elimination. Okay, so the purpose in elimination is to eliminate a variable. So what we're trying to achieve is we're trying to get the same coefficient but opposite signs. So when we add the two equations together, it will drop it. It will be the inverse of it, okay? So if I look right here, I got a positive 1 and a positive 1. So if I take and multiply everything in this bottom one by negative 1, what that does is, let me copy the top one over, it gives me a negative 1x plus 2y equal to 1. Okay? So what we're going to do is we will add 1x and negative 1x becomes 0, hence why we wanted to eliminate the x, and then negative 3 plus 2y is negative 1y equal to 1, and of course divide both sides by negative 1, and then y equals negative 1. At this point, you can substitute either in the top one or the bottom one, doesn't matter. We'll just do it in the top one real quick. X minus 3 times negative 1 equal to 0. So x plus 3 equals 0. And then we'll minus 3. So x equals negative 3. So I still got negative, wait, that's a, oh yeah, sorry, I just found my mistake. Sorry. That should have been a negative 3 here. All right. I just found my mistake on my first one. That should have been a negative 1 here. 3 times negative 1 equals negative 3, so it should be negative 3. So it gives me back the same answer, okay? Gives me back the same answer, and I found my mistake in the first one. So if I'm doing something, please don't hesitate to say, hey, Palmer, I think you made a mistake right there. I'm okay with that, okay? So I work that both ways. So traditionally, if it's in both of them in standard form, like it is right here, I will do elimination. But you could do, excuse me, substitution if you want to, because one of my variables was had a coefficient of positive 1. And it would be easy to solve it in terms of that. All right, so let's look at this one. So I want to kind of walk you through, because this is in standard form. They want us to do it by elimination. So what we're trying to achieve is same coefficient but opposite signs. Okay. So what I do is I check both variables when I'm going through and working this. So I got a positive 1 and a positive 1 on my x. I got a positive 1 and a negative 1 on my y. Okay, so I've reached the criteria. So I'm good, because if I add these, what happens is it gives me 2x, that becomes 0, and that becomes 8. And then I'll divide both sides by 2, leaves me x equals 4, right? Now, I can plug that 4 either excuse me, into the top one or the bottom one. So let's just plug it in the top one, doesn't matter. Give me the same answers. X plus y equal to 9. So I'll plug it, there's 4. So that I'll move this 4 over to the other side. Y equals 5, so here we go. Oh, shoot. When I'm solving this, I get 4 comma 5. That's my answer. Now that tells me that it's going to intersect, right? Anytime I solve for an X or a Y and it gives me a value, then I know that it's going to intersect. Now, doing this algebraically, what you have to remember and kind of keep in your forefront when you're working at these algebraically is this. If your variables were to drop, meaning when you're working these, both of your variables drop, then you are comparing left side to right side, okay, and you're comparing a number, and either the number is equal to it, which would mean that's a true statement, which means they are the same line, which means that's infinite amount of solutions, or that number does not equal the number on the right hand side, which would mean that it creates a false statement, which means that it's a no solution. Okay, be mindful of that. If you watch my eliminations or really both, a substitution when I put them up, they're really, really helpful, and they'll go through that type scenario for you. Okay. Any questions on this one?
No questions.
All right. So what I want you to do is I kind of want you to let's see. I'm gonna hit pause and I'm gonna see what you can do.
So, okay, yeah, I have a question. So, if there is not the same number in front of the X or the Y, then we can't do what we did on the last problem?
Oh yeah. See, there's always a number in front of the X or Y. If one's not there, it's always understood to be a 1, right?
Yeah, but okay, it doesn't have to be the same number, right? To be able to do the.
Oh, you have to. Yeah. What you're doing, either that condition is there, or you're going to multiply one of the equations to get it like that, or multiply both of them. Okay.
Okay.
So looking at this, if I look at -3 and -1, those are not the same numbers but opposite signs. But when I check my y's, I got a -1 and a +1, which means they're the same number, opposite signs. I'm good. I can put the plus here, and then I can add.
Okay.
And this would give me -4x equal to, that went to 0, 28, and then I could solve from there. So what I'm going to do is let you finish this one. I'm going to give you about a minute to finish this one, and then we're going to talk about it. Okay, so I'm going to hit pause. All right, let's kind of make sure that we're got good on this. I'd finish out this problem right here. That's -4 negative 4. So I get x equals negative 7, right? Now I could plug it either back into this top one or this bottom one. Doesn't matter. I'm going to plug it in the bottom one just so you can kind of see that that it's going to work either way. So negative 1 times negative 7 is 7 plus y equals 14. If I subtract 7, that gives me y equal to 7. So my answer is negative 7, 7. Do y'all concur?
Yeah, I got that.
All right. So kind of recapping, I normally write my ones in just because it's easier for you to compare. And so I got negative 3, negative 1. Those aren't the same, so I'll go check my y's. And these happen to be the same number but opposite signs, so my first condition was met, right? So if it wasn't on the y, then we'd have to look at multiplying one of the equations to get that condition to be there, or may have to multiply both of them. So hopefully we have one here. Yeah, we have one here that we'll have to, that won't be true. So let's kind of look at this. I'm going to put a 1 here. I got a negative 1 and a positive 5. Those are not the same, right? Those are not the same numbers but opposite signs, are they?
Mm-hmm.
So, and then I got a negative 3 and a positive 10. Those aren't the same numbers but opposite signs. So I can't just add them together and expect one of my variables to drop because they're not the same number with opposite signs. Now, when I go to eliminate, I normally like to, if I have to multiply something, I normally like to multiply to change my x's because it's right here. So I've got a negative 1. What could I multiply negative 1 by to get a 5? So I could really multiply it by 5. It would give me a negative 5, right? Which is what I want. So if I multiply everything up top by positive 5, I get this. And then everything on the bottom just kind of comes over, right? Didn't have to do anything to it. Now, I got a negative 5 and a 5. Those are opposite numbers, same number of opposite signs. So when I add them together, that drops. I got negative 15 plus 10. That gives me a negative 5y equal to 10. Divide both sides by negative 5. So y equals negative 2. All right. Now when I get this y equals negative 2, I could plug it into either this one or that one. Doesn't matter. But go back. I normally take it back to one of the two original equations, okay? Since this is right here on the bottom, I'll just go ahead and take care of it. So 5x plus 10 times negative 2 equals 5. So it gives 5x minus 20 equals 5. And I will move this over to the other side. So 5x equals 25, and of course divide both sides by 5. So x equals 5. So it gives me a 5 comma negative 2, right? Okay. So that's what I mean by if the first condition is not met, then I'm going to check to see, can I multiply the smaller number to get the bigger number, looking at each variable. Normally times I can do it on the x, right? So that's what I meant. And I took it and multiplied it to both sides of that equation, okay? So I hit both sides of that equation with that 5, which gave me this equation. Any questions on that?
Nope, got it.
I'm good.
Okay. All right. So we've went through graphing, we've went through substitution, we've kind of going through elimination right now. Let's see what we've got next. All right. Now we can do this by elimination, but I'm going to help you clear your fractions first, okay? Let's look at our denominators. 6, 4, and 12. 2, 6, and 3. Well, if I multiply everything in this top equation to get rid of my fractions, if I multiply everything by 12, and then if I multiply everything in the bottom equation by 6, then that's going to help me get rid of my equations or my fractions, okay? Now, I'm not worried about trying to eliminate yet. I'm just worried about clearing my fractions, okay? So if I do 12 times 1, that's 12, divided by 6, that gives me a 2x. 12 times 1 is 12, divided by 4 is a 3, but that's a negative 3, right? And then 12 times 5 is 60, divided by 12 is 5. So that's how the first equation cleared the fractions, okay? Any questions on that? All right, in the second equation, 6 times 1 divided by 2 is a 3x. 6 times 1 divided by 6 is a 1. Why? That's a positive 1. And then 6 times 1 divided by 3 is a 2. All right, so now here's my equations. So what I need for you to do, I need you to take about 1.5 minutes to 2 minutes. I need you to solve this one by elimination, okay? So need you to consider, are they the same number but opposite signs? If they're not, what can I multiply the smaller one to get the big one? And if I can't, if there's no whole number to do that, then I move on to my other variable and see, okay? So just look at that. I'm going to give you, I'm going to hit pause. Okay, so let's kind of look. I'll work you through how I do it. So the 2 and 3 are not the same numbers. Negative 3 and positive 1 are not the same numbers in opposite signs. So now, could I multiply something by 2 to get 3? Not really. I mean, it'd be some kind of decimal of some sort, but no whole number, right? No integer, so to speak. Now I got a negative 3 and a positive 1. Man, I could multiply, if I multiplied this bottom one by 3, I could make that positive 1 be a positive 3, which would give me what I need. So what I've got is, I'm going to give you, there's 2x minus 3y equal to 5. And now I'm going to multiply everything in here by 3, which would be 9x plus 3y equal to 6. And now I've got this condition met, and when I add, they just eliminate. So that's 11x equal to 11, because that went to 0. And then I can turn around and just divide by 11. So x equals 1. Now, I know I said go back to the original, but I'm not going to go back to this one. I'm going to go back to one of the ones in the blue, okay? So 2 times 1 minus 3y equals 5. So that gives me 2 minus 3y equal to 5. And I'll move my 2 over to the other side, which will give me a negative 3y equal to 3. And then let's divide by negative 3. So I got a y that's equal to a negative 1. So my answer is 1, negative 1. So how did we do? Were you able to get the 1, negative 1?
Yes.
True. Yeah?
Yeah.
All right. You feeling comfortable about that?
Mm-hmm.
Okay. So the things that I'm asking, the questions that I'm asking are kind of like leading questions. They help to, when I answer them, they help point me in the direction that I need to go. All right. So let's look at this one. Now we're kind of done with graphing, substitution, elimination. Now we're going into word problems, okay? All right, so hold on, because we got to write equations. We got to do a bunch of stuff, okay? So the only way that you can get good at these is to practice, practice, practice. So I need to show you something. The sequence for 2 two numbers, well, let me back up because they're not consecutive numbers. So let me do this. First off, let's identify who X is and who Y is, because we're going to identify. Once we make that notation, we're not going to kind of steer clear from that. So we've got the sum of two numbers is 30, right? So we know we got two numbers now, and we know that their sum is 30. One number is 4 times the other. Find the number. So we know we have a small number, so we're going to go small number, and then the Y is going to be a large number. Okay, so when we find X, we should have the small numbers value, and when we find Y, we should have the large numbers value. Okay, so here's what we're going to do. We're going to take a verbal expression or phrase and translate it over into an algebraic. Okay, so the sum of two numbers is 30. Well, that would mean that the smaller number plus the larger number has to be equal to 30. Well, that would mean that that's X plus Y equal to 30. Okay? Now, one number is 4 times the other. Okay? One number is 4 times the other. So, larger is equal to 4 times the other, right? The larger number, which is Y. So we have Y equal to 4X. Now, this one automatically set itself up to be a standard form and then a slope-intercept form, which we'll do at this point. We'll do substitution, right? But before we do that, any questions on how I came up with those two equations? The first one should be okay. X plus Y is equal to 30 because you got the sum of two numbers is equal to 30 and is equal, right? But this is the thing that I want to make sure that you're good, this little expression right here. One is 4 times the other, right? One is 4 times the other. So just kind of want to make sure that you're good on that expression. And that's Y, right?
Mm-hmm.
Y is equal to 4 times the smaller. So when you do this, you turn around and say, okay, X plus 4X equals to 30 because I'm substituting the 4X in for Y, right? So I'm taking this and I'm putting it in for the Y. So that gives me 5X equals to 30, and of course X equals 6, right? Now that I know that X is 6, I can plug it back into here and find my Y. So 4 times 6 is Y is equal to 24. So my smaller number is 6, and my larger number is 24. Okay. Any questions about that?
Mm-mm.
All right. You good?
Yeah.
So you got to write the equation, then you got to use one of the algebraic techniques that we talked about, whether it be substitution or elimination. The rest of them, I think, follow suit to be elimination, okay? So let's kind of look at this. Ron has 17 coins, and he has a total value of $2.45. The coins are dimes and quarters. How many of each coin does he have? Well, we'll say X is dimes, or the number of dimes, and that Y is the number of quarters. Okay? And I'll use the pound sign to refer to as the the symbol for number, okay? All right, so what we're going to write here is two equations. They're going to be in standard form, and one of them is going to be a sum. How many do I have? And they're comprised of x and y, right? And then the other equation that I'm going to write is called a value equation. And it's talking about the value of each one of these and how much value do I have total. All right, so let's look at the how many. Now, Ron has 17 coins, right? They are comprised of dimes and quarters. So x plus y equal to 17. Questions?
No.
All right, I can automatically do this. For the second one, and then we'll start to write it. All right, so the other number that I have is $2.45, right? I said the second question will be what is its value for each independent thing and the total value. So I have $2.45, right? Now, I'm going to write this in terms of, instead of writing in terms of dollars, I'm going to write things in terms of cents, okay? And what I mean by that is, how much is a dime worth? A dime is worth 10 cents, right? And a quarter's worth 25 cents. And right here we have $2.45, but that's really, if I write it all in terms of cents, that's really 245 cents, right? And that way it gets rid of my decimals. You know, if I wrote it as $2.45, then I'd have to put a 0.1 and a 0.25, right? And I'd rather not do that. So what I need for you to do is, now you have a system of equations. I'm going to give you just a little bit to, let's see how long you need. Minute and a half, okay, for you to work this, because I really need for you to get the practice of working these, right? So I'm going to give you a minute and a half. All right, so were you able to determine that you had to multiply the top one by -10?
Yeah. Okay, I did a positive 10, so that's where I messed up.
Yeah, you want to do a -10 because what you want to do when you add these, you want the x to drop, right?
Yeah,
go
and that's
away.
what's going to keep school. Because then that would have been 100. Because I was like, yeah. Okay, so negative will cancel the positive.
That's right. So, and that'd give me a -10x minus 10y equals -170. And then, of course, the bottom one I don't do anything to. And then that's 25y equals 245. Now that I've got this condition met, a -10 and a +10, now I can add, which means they will eliminate, they'll go away, right? And then I'm left with a 15y equal to, what is 245 minus 170, right? 75?
Yes.
And I think,
okay, that looks
go ahead. You good. Go ahead.
No, that's, yeah, that, because I got like 35 over like 30, I had like 35y equals 415, and I was like, I couldn't figure out where I went wrong.
Well,
but it was negative.
Yeah, if you didn't multiply this top one by -10, then you would have had 10 plus 10, which would have gave you 20, right? So that tells you whether what you've done thus far is correct or not. So that's what you got to consider. Okay, so I know that I've got y is 5, so my y is quarters, so I got 5 quarters. And then I can, of course, come back in here, x plus 5 equal to 17, because I plugged it back into the y right there, right? Write that above that. And then minus 5, and that gives me x equals 12, right?
Yes.
So Ron had 12 dimes and 5 quarters, which gave him a total for 17. 17 coins, which if you do the multiplication on that, everything comes up to be $2.45. And the really cool thing about this problem is you can take two denominations, like quarters and dimes or quarters and nickels or nickels and dimes or whatever. It doesn't matter, just as long as you have two. And you can put them all in a bag together, and you can know how many total you have, like how many coins total do you have combined of both, and then how much dollar amount. And you can turn right back around and write the equations and solve it and come up with exactly how many of each one. So this type of problem, if I were you, I would take I'd take some dimes and nickels and stuff, and I would kind of create me a problem and then work it out to verify, and it works out. So that's excuse me, I don't know why I'm coughing so much, but hopefully I'm not hurting your ears. But this is a really good problem to do that with, and I highly suggest that. So, all right, any questions?
I think I'm good.
Okay. All right. So on this problem, I'm going to work it two ways. All right. I'm going to work it with a table, which is normally how I would teach it in a regular college algebra class. Let's see. It says I may be experiencing degraded audio. I don't have anything. Let's see. I got this, maybe. Make that go away. And this, I don't have anything there. That's not doing anything, so make that go away. Okay. I'm not sure why it done that, but all right. So let me show you how to work this, and then I'll show you how to set it with a system, and then you can solve the system to do that as well. But we have a mixture of a 6% disinfectant solution, and it's to be made from 7% and a 4% disinfectant, right? So I got a 7 and a 4, and I want to mix them together to come up with a 6% solution. How much of each one do I need? If 33 gallons of the 6% solution's needed. So in the end, my final product is a 6% solution and 33 gallons. Okay, so here's how I'll do this. I go items, okay, and then I go amounts, and of course we're in what? Gallons, right? So gallons, and then percent solution, and then total. Okay, so item first one is a 7% solution, and then my second one is a 4% solution, and what I want to end up with is I'm going to do it in blue, 6%, right? 6% solution. So that's pretty standard. So I got a 7%, 4%, and a 6%, right? So so I've got the items category. I got two things I'm mixing together to make something. So now gallons. Well, I know how many 6% I need to come up with, right? 33 of them, right? So let's kind of look at this. I don't know how much of the 7%. So we're going to put X, right? And if I don't know how much of one, and I do know how much of the final amount, then here's a little algebraic trick. 33 minus X, whatever X is, if I do 33 minus X, that would tell me how much of the 4% solution that I've got, right? Y'all good with that? It's kind of I hate to say that's kind of confusing, but
So you made 6%. So we have to have 33 gallons of 6%.
that
And then
was
you
what I
just
knew. That's right. Hmm.
so then you just chose to make the 7% X.
Uh-huh.
So it didn't really matter. You could choose to do the 4% X either
Yes,
way.
that
Or-
is it.
Okay.
Yeah, that is
Okay.
exactly correct. Good question, Stephanie. I could have made 4% to be X here, and then the 7% would have been 33 minus X, right? Now,
Right.
would you believe that you're 90% done? So let me show you what we're about to do. The percent solution, well, that's a 7%, that's a 4%, and that is a 6%. Now, we're going to multiply these to equal this, right? So X times 7 is 7X. And then this would be 4 times 33 minus X, right? And then let's do 33 times 6, which is 198. Okay. Now, any questions about how I took and got the totals? I took this one times that one to get my total, right?
Mm-hmm.
All right. So now let's think about, I'm taking this product plus that product, and it better equal, guess who? 198, right? So you could go 7X plus 4 times 33 minus X equal to 198. Okay. So what I want you to do, if you're good on that equation, okay, I want you to solve it, and then I want you to find out. Now, X is going to be 7%, right? So I want you to be able to tell me the 7% solution, how much we got, and then how much we got in the 4%. So that if we were to mix them together, we would have 33 gallons of a 6% solution, right? Can you solve that for me? If I give you about a minute to do that, that'd be good.
Yeah.
Minute and a half?
I
You want a
think
minute
so.
and a half?
Yeah.
Oh, yeah, okay. All right, so I'm going to give you a minute and a half. I'm going to hit pause.
I got the X equal, but not the other part.
Okay, so let's do this. So I got 7X. What's 4 times 33? Let's see.
132, I think.
132?
132.
All right, minus 4X equals to 198. So that gives me, if I combine like terms here, that gives me to be, what, 3X plus 132 equals 198.
Mm-hmm.
And then if I subtract 132, that will give me, let's kind of go back up a little bit, that'll give me 3X equals 198 minus 132 gives me 66.
Mm-hmm.
Excuse me, and then divide by 3. So X equals 22. Now, that's what I got for X, okay? Y'all agree with that?
Yes.
Stephanie, you okay?
Yeah, I don't know. I don't know why, but I tried to like subtract the 7. I didn't combine like terms. So
Yeah,
that's why I messed up.
yeah, you got to combine like terms. And you'll have that scenario every single time when you work one of these problems, okay?
Yeah.
You'll have a like term that you'll have to combine before you do that. So once I get X is 22, I'm going to do you okay?
Yes.
Okay. So once you get X is 22, then you know right here that, okay, the 7%, I need 22 gallons, right? So 33 minus 22 will give me 11, right? So I will need 22 gallons of the 7% and then 11 of the 4%.
Mm-hmm. Okay.
Okay.
All right, so y'all see how we got that?
Yes.
Yeah.
So, okay. So, hold up for one
Can we
second.
just scratch that?
Do what now?
Can we just scratch that one? Oh my god.
All right. No, I can't scratch it. That's one of those problems that you really, 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 really got to know. Okay.
Okay.
I know. But this table, if you'll do it and then look back and look at this and kind of watch it and see where numbers came, you can get back to the black equation right here. Okay. And then it's just a matter of solving it. And you'll get your confidence up and you'll be like, oh man, that's an easy problem. Okay. Yeah. Y'all are just still not believing me, are you? No, y'all are not. Okay. All right, so let's kind of show this real quick with a system. Now I'm just going to set the system up, okay? You can solve it, but it'll give you the same numbers, okay? So what do we have? Yeah, okay, I'm going to keep it so that that's a 7% solution. This is the amounts, right? And then a 4% solution. So, all right, so it said that we had 33 gallons, right? And the 33 gallons were comprised of the gallons of the 7 and the gallons of the 4. Okay, so that's where that comes in. Now the other part of it's this. I told you you could just about do this right here on the bottom equation just about every single time. So I'm going to put a 7%. Here's 4%. Now equal to, let me get this number down here, 198. Now let me show you what this 198 is comprised of. It's comprised of 6% and 33 gallons, right? That's where that number came from. 6 times 33, 198. Okay. So if you were to multiply this top one right here by -7, you would be able to drop your x's, and then you would be able to find your y, and then plug it back in to find your x. Okay. So that's how you set up as a system. So you have a totals and then amounts as far as value. A 7% solution times the amount of gallons plus a 4% solution times the amount of gallons equals 198, which is the 6% solution times the gallons, right? That's really what that number is, right? Solution times gallons give you 198. So that's how that bottom equation is made. That makes a little bit more sense. And you might like it that way. I don't know. But you've got both ways that you can go back and look at and kind of decipher which one you want to do. Because remember, right now I'm in the driver's seat. I'm pointing you. I'm going to leave it right there for a second. I'm pointing you in the direction that your thoughts need to go. So when you get to working these on your own, you're driving the bus. So don't be discouraged if you get to a point you're like, I can't, I don't know what to do, because okay, you're learning this. So what I advise you to do is go back and watch the video and rework that type of problem, and then go back and try it again. That's what I highly suggest. So it'll keep your level of frustration down, I should say. All right, so let's see. We should be almost about done. No, we got that one. and then that one. Okay. All right, so we got two of them. Then there's we really got three, but that last one I'll show you how it's worked. All right. So let's kind of look at this. We got 800 tickets that were sold for a game, and they took in $1,225. Okay. They sold adult tickets for $2, and they sold children's tickets for $1. How many of each ticket were sold? Well, I think by now you should be able to go, well, X and Y would be adult and child, right? So we'll go adult, and then we'll go child. All right. Now, here's the cool thing. This works very much like the coin problem that we done 2 problems ago. And I know you're going to go, Palmer, what are you sniffing or eating or drinking over there? Because that ain't no way. It is, I promise you. How many tickets did we sell?
800.
That's right. So they were comprised of adult tickets and kid tickets, right? Now, I want to show you what the other numbers that are left are. Those are values, right? Wouldn't you agree?
Yes.
Mm-hmm.
Okay, now watch what I'm about to do. How much does it cost for an adult ticket?
$2.
$2.
Oh, okay. How much for a child ticket?
$1.
Okay. For a total, how much money?
1, 2, 3.
Okay.
Well, how about that? Didn't we write the second equation?
Yeah.
All right, now listen. I didn't take these back into cents, okay? These are going to be strictly dollars. It's only the coin problems that I take back into cents, okay?
Mm-hmm.
All right. Now, so here's my 2 equations. I need you to work them. I need you to solve them, okay? So can you do that for me?
Yes.
Yes.
All right, so I'm going to give you, how much time do you need? Minute and a half, 2 minutes?
Do
Which
2
one?
minutes.
Okay, I'll give you 2 minutes. All right, so I'm going to pause the record. Okay, so here's first things first. I'm going to, I don't have any of them that are the same numbers but opposite signs. So can I multiply something by 1 to get 2? Well, I can, but I need to make it a -2, right? So this is going to give me -2x minus 2y equal to -1600. And then I have on the bottom 2x plus 1y equal to 1225. And because I have a -2x and a positive 2x, that gives me 0. -2y plus 1y is -1y. And if I do 1600 or -1600 plus 1225, that would give me 375. And of course, well,
-75? No.
ma'am,
Oh, no, -375.
yeah. And divided by -1, so y equals 375. So my y is my kids, right?
Mm-hmm.
So I sold
I
300.
did it different, but I got the same answer.
You will. If you were to, did you drop the y?
Yes. Mm-hmm.
Yeah, that's fine. If you multiply it by -1, that's fine. It doesn't matter whether you eliminate the x or eliminate the y's. You have to eliminate one of them
Mm-hmm.
so that you can, excuse me, so you can solve. So what it's going to give me is x plus y equals 800. I'll use the top one, right? Excuse me, top equation. So I have x plus 375 equal to 800. Let me move this up. So I'll minus 375. So x equals, and I'll do 800 minus 375, because if I know I sold 800 tickets And if 375 of them were kids, then that leaves me with 425 of them that happen to be an adult. So there you go. What do you think?
That one was easy.
Yeah, you should start to feel a little bit more comfortable with them by now as you're progressing through and stuff like that. So, all right. Any questions before we leave this one? Y'all good?
I'm good.
I'm good.
Okay, Amadou, you good?
Yes, I'm good.
Okay. Guys, I'm putting these videos up on the very top, so you don't have to go search for them on your online videos within Blackboard. So there'll be a date and a section, and like 4.1 and 4.2. So you'll see that. You know that those are yours. That's per our help session or our class session, I should say. And then tonight's will actually be underneath that. So that the top two, besides the one that says online help session, that's where you can find it. You don't have to go scrolling down in it, okay? So I wanted to kind of make sure that y'all were good with that. All right. So here's this one. We're going to do it. So I want you to kind of look at this equation. I equals PRT. Okay, I equals PERT. PRT. I is the interest, P is the principal, R is the interest rate as a decimal, and T is time. Okay, so that's kind of how we're going to set this up. Now, Mr. Jones wants to invest $21,000. He wants to put some of it in 8%, some of it in a 12%, but he wants to earn $2,040 in interest after 1 year. How much did he invest in each rate? Well, what you have to understand is, what we will have is, we will have kind of like this, a P times R, and then a P times R, right? Does that make sense? Because the time is 1 year, right? So I don't have to worry about time. Because if I multiply anything by 1, what happens? It doesn't change its value, does it? All right, so let's kind of see. How much did he put in the 8%? Let's do this as 8%. That's 0.08. How much money did he put in there? You know the mixture problem where we done that little algebraic trick? So we're going to say he put X amount, okay, in the 8% account. Then in the 12% account, he will have put 21,000 minus X, right? So if you tell me how much you put in at 8, if I do 21,000 minus that, that will give me the rest of the balance, right? Rest of the money to put in that other account. And then that's times 0.12 because your interest rate has to be as a decimal, right? Now, the interest that he wanted to make was $2,040. Okay, so I'm kind of get you started on this. So this right here becomes 0.08x, right? And if I distribute this in, what that gives me is 0.12 or 0.12 times 21,000 is actually 2520, and then this times that gives me negative 0.12x, and that's equal to 2040. Okay, so I kind of want you to kind of look at that, kind of digest how I made that be, how I came up with that, and where the numbers came from. and everything. So kind of take a look at that before we start solving this. All right. So, we've got, are we good on what we've done so far?
Mm-hmm.
Y'all sure? Understand where
Yeah.
the numbers came from and everything? So now we're going to combine, right? And when we combine 0.08 and negative 0.12, we get negative 0.04x plus 2520 equal to 2040. All right. And the really cool thing is, because I know that my coefficient of x is negative, when I move this over, I know I'm going to have a negative over here, right? Because I want a negative divided by a negative to come out to be a positive, right? So 2520 and 2040 is 480, and that difference happens to be a negative 480 because I got a negative 2520 there, right? So when I do this and divide both sides by 0.4, I get an x of 12,000. So now, who did I have as my x?
8%.
My 8%, right? So I put in 12,000 at the 8%. Now, how much did I have to invest total?
21.
Right. So if I do 21,000 minus 12,000, you should
9.
see that I get 9,000 out, right?
Mm-hmm.
Any questions about that?
No.
You want me to show you how to do it as a system?
I think I'm good on here.
I,
I'm a
I,
bit confused.
yeah, I think I'm good too. I think the decimals are just throwing me off, but there's really no point for it too.
Mm-hmm.
Okay. Well, I'm just going to set it up. You don't have to look at it. There you go. And if you look at that, you can, and let's see, x is amount of 8%, and the y would be the amount of 12%, right? So you'd have all that. But I think probably the easiest thing would be to do what's right here.
Mm-hmm.
So just, but you've got it if you want to, if you want to solve it, that's fine. So now I want to look at this one because this one is, it's not a hard one. And actually they give you everything you need to know. And I didn't hit erase on this because I just keep all my work right there. All right, so they tell you that a stuffed animal business has a total cost of production of 12x plus 60 and a revenue function of Rx equals 20x, right? Find the break-even point. Well, if you look at the question, it says break-even point at x equals 7 or x equals blank, where R of x is equal to C of x. So basically all I did was this. I took the equation, set them equal to one another, and solved for x. That's all I did. And I moved the 12x over. That gave me 8x equal to 60. Divided both sides by 8. So my x happened to come out to be 7.5. Okay. Now, this would be the x value, or the input. And then this right here would be the output when x is 7.5, right? So if you take 12 times 7.5 plus 60, you will get, guess what? 150. And if you take, the cool thing is, if you take 20 times 7.5, guess what you get? 150. So that's it. It was take these, set them equal to, find the x value that makes them both equal, and then plug it in to find its outputs. That's it. So,
Okay.
all right. So that's all for 7.1. Okay. Now, I want to look at this one. We're going to get started in 5.1, but we won't finish it tonight. Okay.
Do
But
we have
I
class
will.
on Monday?
Yes, we have class back on Monday. Yeah.
Okay.
Now you do have a test that opens tomorrow, chapter
Mhm.
3, right?
Mhm.
Okay. So what I probably will do is, we have this one, 6.1, 6.3, 6.5. Okay. And we got really 3 class meetings left. I will tell you this. Our final is on the 24th. I'll be sending that out in an email. It's on the 24th. So it's 2 days after our class ends. And it'll be, I think it's at 5 or 5:30 in the auditorium. They're going to do all math finals in the auditorium together. So we'll be in there with my 16-week class and another class. So,
So it's not on the computer?
no. It's a face-to-face multiple choice.
Okay.
And I've got Scantrons for you, so all you have to do is bring pencils or some kind of writing device and a calculator. Because if you look at the final exam information within Blackboard that I have posted, it has a formula sheet which you'll get the night of the final, and it will then it'll be over the content that's in that final exam review. So,
Okay.
all right. So we're going to get started on this, and we'll probably go to about 8:20, about another 15 minutes. And then we'll pick up on this on Monday and do 6.1 with it. Okay. So 5.1 and 6.1 on Monday. We'll finish 5.1 and 6.1 on Monday, and then we'll do 6.3, 6.5 on that Wednesday. And then hopefully we'll be able to come back in and review on the 20. Let's see. Check my dates real quick. Calendar. Oh no, we're good. We're good. Yeah. 8th, 10th, 15th, 17th, 22nd. We're good. We'll come back in on the 8th and finish 5-1 and 6-1. The 10th, we'll do anything in 6-1 that we haven't done, the 6-3, 6-5, and that'll leave us maybe a day or two to do a review, maybe that 17th and all of 22nd. Okay? And then your finals on the 24th.
Okay.
So we're sitting pretty good. All right? Okay. All right, so let's look at 6-1 or 5-1. We're going to look at, it says the general form of a quadratic, but normally this ax squared plus bx plus c, traditionally, mathematically, we call it standard form. Okay? And then what they're saying that is standard form, where it's f of x equals a times x minus h squared. This form right here, let me grab it, highlight it. This form right here is normally what we are used to or traditionally call vertex form, right? Because you can pull the vertex out of it very quickly. And what I mean by vertex, that would be my h and my k. And remember, if I pulled the h out, it would have to change signs because it's x minus that h, right? Anytime a formula is set up in x minus something, it's always going to change your signs. So just kind of be aware of that. But the k doesn't change. Whatever it is out here, that's what it is there. So the quadratic formula started out with negative b, right? Over, plus minus square root of b squared minus 4ac all over 2a, right? With this h value, the vertex for quadratic is negative b over 2a. That's how you can take any equation that's a quadratic and be able to find its h value. Then if you plug it back in, it's kind of like a t-table. If you got an x and you got the equation, if you substitute the input in, evaluate it, you'll get the output, right? So that's kind of what that is, and that's what we're going to do. So some things here to kind of make sure you understand is if a is positive, whether it's on this vertex form or the standard form, either one, if a is positive, it will open up, and if a is negative, it'll open down. And what we're looking at when it opens up, the vertex right there will be a minimum, right? We've kind of talked about that. And then if the vertex opens down, or the quadratic or parabola opens down, then that vertex on this happens to be a maximum, right? Y'all remember doing this?
Mm-hmm.
Okay. So kind of getting back into quadratics a little bit. So they just need you to kind of understand that. Don't worry about this one because it's really a confusing way to show you how to substitute something back in, and don't worry about this. We'll talk about domain and range in a second, and don't worry about that. And this is just some how-tos. So, all right, so let's kind of rewrite the quadratic function in standard form, right, and give the vertex. So here it is, x squared plus 4x plus 7. So what you have to understand is here's ax squared plus bx plus c, right? So we know that a equals 1. There's a 1 right there, right? And b equals 4. Okay, so what we're trying to do is we're trying to put it back in this form. Y equals a x minus h squared plus k, right? So we need to find, what we're trying to do is we're trying to find the h and we're trying to find the k. So h happens to be negative b over 2a, right? That's the formula for finding h. So we put out a and b. So here's how I kind of do this. This is negative b. So I normally write it like this. Negative 1 times that, and then 2 times this. So b happens to be 4, and a happens to be 1. So what I've got is negative 4 over 2, which is negative 2. Okay, so my h value is negative 2. Kind of take that in and kind of digest that for a second. I plugged my b in, I plugged my a in into the equation negative b over 2a, evaluated it, and got an h value that is negative 2. Okay, so I can, when I get this h value, I can come down here and I can put in negative 2. Now, the reason why I can put in negative 2 here is, instead of having to put in a positive, you see how they hard-coded this? X minus there. They've hard-coded it in, so I don't have to worry about changing the sign on this one. But all the other ones that are not hard-coded in, you're going to have to, okay? Now, this is the A. The A up here is the same A here, so that's a 1, right?
Mm-hmm.
Now, if I've got an input, let's kind of think of it like this, x, y. If I've got an x value that's negative 2 and I want to find the y, then all I'd have to do is plug it back in, right? But when I say x and y, I'm really talking about h and the k of the vertex, right? So, erase that. I'm going to plug it back into this equation. I'm going to go 1 times negative 2 squared plus 4 times negative 2 plus 7. So what that gives me is 1 times 4 minus 8 plus 7. So that's 4 minus 8 plus 7. So that's negative 4 plus 7, which is 3. Okay. Any questions about what I just done with this 3?
Mm-mm.
So I took my h, which is really an x, right? Plugged it back into this equation to get my y, which is really the k. And I got my k to be that. Okay, so my vertex is negative 2, 3. Questions? And make sure you digest that, kind of work through that, look at where things are. They call it H and K because it comes from the conic sections. You remember when you studied ellipses, what we call quadratic is really a parabola at that time. Circles, ellipses, hyperbolas, all 4 of those are made from slicing a cone, hence why they call it the conic section, at different different angles or different slice patterns. Okay, so any questions on this? Y'all good?
Mm-hmm.
Yes.
The biggest thing is use this equation to find your h, plug it back into the main equation to find your k, and then you're good. You got your h and your k, and your a is the a of the original equation. That doesn't ever change. All right. Now, determine whether this is a minimum or a maximum, and then find the value of the axis of symmetry. Okay, first off, here's your A, right? I don't like to do that. Here's your A. So your A is 2, and it's positive, right? So think about a smile when you're positive. The smile does this, right? So it opens up. So therefore, your vertex would actually be a minimum, right?
Mm-hmm.
Because the A is positive. The A is greater than 1, right? Or greater than 0, period. I shouldn't say greater than 1. A is greater than 0, right? A is greater than 0. If it was A was less than 0, it would be negative, and it would open down, right? So just kind of be aware of that. Write that 0 a little bit bigger. And we need to find its value. Well, that's really finding the vertex, right? And then we need to find the axis of symmetry. Now, the axis of symmetry is nothing more than x equal to h value. Okay? That's really what the axis of symmetry is. So what I need for you to do, I'm going to pull out your A. Your A equals 2, and your B equals 4. And I'm going to give you this equation right here. So I'm going to ask you to go find me the vertex. Okay, because that's really what your maximum or your minimum is. All right? So just like we done on the previous problem, you're going to do it again, but now you're using a different equation, right? You're using this one. Okay? So if I give you a minute, half, 2 minutes, you could find me the vertex and the axis symmetry, which is once you find the H on it, you're good, right?
Mm-hmm.
So I'm going to give you 2 minutes, and this will probably be the last problem we have for the night. So let's see what you can do, okay? Let's end strong. I got an H value of -1.
Mm-hmm.
How'd y'all do?
The same.
The same? Okay, so I'm going to plug it back into the original equation because we're going to say K is equal to this, right? And sometimes you'll see it F of H because they're plugging the H value back in to find the K, right? Plus 13. So kind of do this, raise it up just a little bit. -1 squared is +1 times 2 is 2, minus 4 plus 13. So it's -2 plus 13, which is 11. That's exactly right. So my value, that's my K. So it's -1, 11. That's my value for my minimum, right? And then my axis of symmetry, x equals -1. Any questions on that? How did you do?
Good.
Okay.
Good.
All right. So what we're going to do is we're going to call it a night because I don't want to go any deeper. I could go for about another 10, 15 minutes. But you really need to start kind of switching gears and making sure that you're ready for getting prepped and ready for your test at closest Sunday. All right. So I'm going to put a good bit of resources up online in the videos. This will be up there. Plus, I'll have some videos that have solving systems with elimination and substitution. So I'll put those up, and I'll put that in a probably put that, make a little another like I have online in another box. I may just create one that says substitution and then or solving systems, and then you can look in there and get everything that you need. So all right, so remember, you got a chapter 3 test that opens tomorrow. You don't have to take it tomorrow, but whenever you do take it, it's 2 hours. And it's going to cover a good bit of stuff. What we're doing tonight kind of ends the last test that you'll take online. Okay, so what we done Monday and Wednesday of this week is really chapter 4 stuff. So just kind of be mindful of that. You know, you got linear and then systems and then these quadratics. So kind of compartmentalized. But if you look back on chapter 3, it'll show you which ones they are as far as what you need to make sure that you're prepped on. And if we look right here, while I got you, it should be 3, 1, 3, 2, 3, 3, and 3, 5. 3, 1, 3, 2, 3, 3, and 3, 5. I think yep, that should be it. 3, 1, 3, 2. And so that closes 4, 7. Okay, to open up tomorrow and close 4, 7 for you, okay? And yeah, that final exam's not 6:30. And we'll probably scratch 6, 7. Give you a day in there, okay?
Okay.
So, okay. We'll call it a night. I'll get this going for you, and let you get prepping for that. And we'll kind of go from there. All right. We'll see you back in class on Monday.